This is a video on conditional probability. This is day 14 in the probability unit. So the example says here, two number cubes are rolled, and the first cube shows 6. Find the probability of each event below. So the trick is here that we already know something that happened. So it's not going to be part of our probability. It does affect the probability we're about to do, but it's not going to be part of our probability. So how we would write this is we say probability that the sum is 9, and then this line right here it means given that the first cube shows a 6. So we're going to say given that we already know we have a 6. So if we already know we have a 6, we have to think about all of the possibilities of what this number cube can be. So if we have 6 already and we roll the number cube, the only way to get 9 by adding them would be to have 3 on the number cube. So that means that this has to be a 3, and we think of what probability it would be to roll a 3 on a number cube. So there's only one 3 on the 6 faces, so it would have to be 1/6. So really the key thing is that this guy means given, and this thing is what already happened, so it's not going to be part of our probability. So the next one says probability that both numbers are even. Again, given that the first cube shows a 6. So that will look like this. Probability both even. Again, given that we have a 6. So we have to think about what the other dice could be. We already know that 6 is even, so this is going to happen, or it could happen. So this other die can be 2, 4, or 6. And so that's 3 options out of 6 total. So that's 3, 6, or 1/2. Again, we don't care about we do care about what already happened, but it's not going to be part of the probability we calculate because it's happened. We're only worried about the next thing. And this next thing does depend on what happened because it's going to limit our sample space or the amount of options that this other die can be. So probability that the sum is greater than 8 would look like probability sum is greater than 8 given that we already have a 6. So think about the possibilities of what could make the sum of 6 and some other number be greater than 8. So the faces are 1, 2, 3, 4, 5, and 6. We know that 6 plus 1 is 7, so that doesn't work. 6 plus 2 is 8. That is 8, but it's not greater than 8. The sum isn't greater than 8. 6 plus 3 is 9, so this one works, and then all of the rest will also work. So that means we have 4 options. This is 4, 6, which is 2/3. So again, one probability because of the given. Our last one's a little bit more tricky. It says the sum is greater than 9 and less than 12, but again, given that we have a 6 already on one of the number cubes. So I just wrote it as probability of sum greater than 9 and sum is less than 12, given that we have a 6 on the other number cube. So we have to think about the options of the only number cube left, and you write them down: 1, 2, 3, 4, 5, 6. Pardon the handwriting. And so 6 plus 1 is 7. That's not greater than 9 and less than 12, and less than 12. 6 plus 2 is 8. That's not greater than 9 and less than 12. 6 plus 3 is 9, not greater than 9. And then 6 plus 4 is 10. That is greater than 9 and less than 12. So that fits both criteria. It counts. 6 plus 5 is 11. That is greater than 9 and less than 12. That fits both criteria, so it counts. And then 6 plus 6 is 12. which is greater than 9, but it's not less than 12. It is 12, so that doesn't count. So when we have two options we can get for that probability to fit the criteria, it's 2/6 or 1/3. Yay! This is what's called a two-way table. So, well, it's more than a two-way, but there are a lot of options here. There's many things happening. We have counties in Texas that voted for Bush or Kerry or someone else in the 2004 election. And this is in thousands, but let's just worry about these numbers here. So it is helpful to figure out the totals, but we don't know which totals we need yet. So we could figure out all the people who voted for Bush and add it up. If we wanted, it would be, right here. And all the people who voted for Kerry, we could add it up and be right there. And all the people who voted for someone else, and that would be right there. And we could also figure out all the people who voted in Travis County, and that would be, right there. And so forth. But we don't really know what we need for the questions, so it may not be necessary to find all of them. So we're going to figure out the probability that a voter from Tarrant County voted for George Bush. This is where it gets confusing because we need to know which part is given. So it says a voter from Tarrant County voted for George Bush. That means we know that they're from Tarrant County already. What's the probability that they voted for George Bush? So this would be probability of voting for Bush, but it's given already. We know this, that they are from Tarrant County. So we would say that we now have to limit our focus just to the people who are in Tarrant County, because we already know this. It's the only thing we care about right now is the people that are in Tarrant County, because we know that the person we're looking for the probability of Bush, but we know that they're from Tarrant County. So we are limited in the sample space that we can choose from. So our probability is that, how many people voted for Bush that fit this criteria in Tarrant County? So that would be this amount right here, 349. That's going to be our top number, our number that fits the criteria of voting for Bush. And then our denominator is the sample space. The sample space in this case is 349 plus 207 plus 3. Those are all the people in Tarrant County. So that's 559 total of Tarrant County. What fits the criteria is the number of people who voted for Bush. So you would divide the two, top by bottom, and you get 0.624, or 62.4% is the probability of people who voted for Bush given that they're from Tarrant County. And then the next tricky part, so we have one tricky part with that given. We need to figure out what is being given in the situation. What do we know for sure? And then what are we looking for? People voted for Bush from Tarrant County. But part B here is asking a different question, that a voter voted for John Kerry and was from Dallas County. This and thing, whenever we're talking about conditional probabilities, this is really the other thing we need to know. There's basically two main tricks about this, about conditional probability. One, we need to know what given means. And two, we need to be very careful with the word and. We know that the voter voted for John Kerry and was from Dallas County. So whenever we see the and, we are comparing it to the total. We're comparing it to the total number of all people who voted. So we're looking for people who voted for Kerry and from Dallas County against the total. So that kind of looks like this. So I added up all of the people who voted. So there's, all the people who voted for Bush, all the people who voted for Kerry, and all the people who voted for other. And I got 3125. So that is the total amount of voters that are in this table in thousands. So a voter voted for John Kerry and was from Dallas County. That is only that number. That is the only number that fits that criteria, because the criteria is Kerry and Dallas. So it has to fit both criteria for us to use it. So in this case, our probability would look like probability of Kerry, and Dallas. So that's only 336 over 3125 against the total, because it's an and. So anytime you see this and thing and there's not like a given, or there's no given to be found, you have to go the criteria that fits it against the total. So this is 336 over 3125. And again, they're in thousands, so it's 3,125,000. And I get 0.108, I round it up, and which is 10.8% chance. So that's the first video in this lesson. I'll make one more video of another example, and then there's going to be another video of a couple homework problems. Yay, good luck.